All right. So again, we're taking a look at the spore sizes, the mass, median, aerodynamic diameter, and essentially when we see that the device has a cut value of 2.5 micrometers, well, unfortunately, a lot of our organisms that we're interested in are in that range, right around 2.5. And so this just simply tells us that if we're looking at a spore type whose mass, median, aerodynamic diameter is, say, 2.5 micrometers, if there's 1,000 spores per cubic meter of air, and we collect the sample, it's going to report it as 500 spores per cubic meter of air. There's a non-linear relationship between spore size and capture efficiency, and some researchers have suggested that it's a power function, meaning that a change of unit size is going to result in an order of magnitude in capture efficiency, up or down. So it's not a linear relationship, which dramatically changes the spore results. So let's go back to our original question. We've got a certified mechanical hygienist has gone out and he's collected a sample indoors and he's collected a sample outdoors, and he's concluded that because there's 2,283 spores per cubic meter of air indoor sample and there's only 1,233 spores per cubic meter of air in the outdoor sample, that this proves beyond a shadow of a doubt that there's a mold problem within the building. So in this particular case, we've already mentioned we've got 2 aerosol samples, or Anderson or Burkhardt or any other kind of a spore trap, collected from the same residence, collected same time, same equipment. We're even the same temperature. Everything's the same. So let's try to keep these two as close together as we can, so that we're just looking at comparing the data. So is 2,283 spores per cubic meter of air actually higher than 1,233 spores per cubic meter of air? Let's play the numbers game. Let's find out. So sample number 1, this is going to be the sample that was collected from the outside, reported as 1,233 spores per cubic meter of air. What we look at is in our species that are present, this is the profile, and these are the organisms we're going to say is present. This is the size, the aerodynamic diameter, the mean aerodynamic diameter in micrometers. This is the collection efficiency based on that size. This is the actual spore concentration present for each one of those components. Spore A, 534 spores per cubic meter of air, etc. And then, of course, when we get down to the actual cut value, we see, for example, since it's 2.5 micrometers, the cut value is 0.5. So what's reported is going to be exactly half of what is actually present. So for the reported values, this is what is trapped and retained in the spore trap. That's what, therefore, is available for the laboratory to count. So for sample number 1, we see that there's 3,949 spores per cubic meter of air, and that is being reported by the laboratory as 1,233 spores per cubic meter of air. That's our outside spore concentration. Now, let's take a look at our inside spore concentration. We have exactly the same spore profile. The individual, and therefore we have the same, obviously, the same sizes and the same collection efficiencies. The individual components of each spore type, however, is a little bit different. So the spore profile is the same, but the concentrations of each individual component are going to be slightly different. That is just a reality of life. You're going to find that in every single sample ever collected. That's just all there is to it. So the laboratory then has reported their value, and what we see for sample number 2 is for 3,949 spores present per cubic meter of air, the laboratory is going to report it as 2,282 spores per cubic meter of air. Now, let's go back to sample number 1. What was the result? Well, there was 3,949 spores per cubic meter of air, reported as 1,233 spores, and for sample number 2, there was the exact same spore concentration present, but the laboratory reported something completely different. The guys running around collecting these samples, they have absolutely no idea that this is what's going on. They haven't got a clue. They get this number back from the lab. They assume that that number really represents the spore concentrations that are present. 99.999% of these so-called certified mold guys, they have no idea what is going on in their sampling equipment. They don't have any idea how to interpret the data. But more importantly, they know that you don't know how to interpret the data. And as long as you don't know, they can still bamboozle you. And that's what this is all about. This is all about playing the numbers game and just simply trying to sell people snake oil and make it look like they've done something very scientific when all they've done is taken your money, they've done the dog and pony show, and now you think that you've got something for your money. So now we know that there's huge variations with time, there's huge variations in space with regard to small distances of samplers. Let's take a look at what has also been known for decades, and that is the laboratories themselves are entirely incapable of reproducing their data. If I collect, say, a benzene sample from a factory, or I collect an acetone sample from a factory, or what have you, and I submit that sample to 10 different labs, they're all pretty much going to come back with the same number. If I take that same sample and I split it correctly and I send it to the same laboratory 10 times, that laboratory is going to reproduce that number very, very well. In the case of the spore concentrations, people think that oh, the lab gets this and they plug this into some fancy instrument that's got a lot of lights flashing and bells and whistles are going off, and some scientist in a white coat is feeding this thing with a syringe into a gas chromatography mass spectrometer and it's got Zeeman correction and I don't know, the gravitational lines around it are all corrected. Oh, no, that's not at all what's going on. You got a guy that's sitting back with a cup of coffee. Oftentimes what they're going to do is they're just going to look at the bag. They're going to identify it, or they're going to mount the thing, and they're going to count it, and they're going to do their best. But it's very subjective. And so because it's very subjective, what we find is that laboratories can't reproduce their data. So in this particular study by Robertson, we've got an example of 4 samples submitted to 7 different AIHA accredited laboratories. The laboratories, they're not doing anything wrong. But in the case of sample number 1, for example, we see that the low reported at 40 spores per cubic meter of air. Another lab said, no, there's 1,933. Everybody else was in between those two. For sample number 4, we see that the low value was 3,700, high value was 30,000. Everybody else was somewhere in between there. The standard deviation is huge on each one of these. So what does this tell us? This tells us that if you're a certified mold inspector and you've collected a sample in somebody's house and you've convinced them that based on that sample that they've got a real problem, and so you're going to spend $20,000 cleaning that property from this terrible toxic mold, then you go back in and you do your clearance sampling, and that sample comes back higher than when you started, then you got a problem. How are you going to explain that to the client? Answer, you're just going to keep submitting that sample over and over and over again to either the same laboratory or a different laboratory until you finally get the number you want to see. And then that's the value you're going to show the client, that laboratory report. You're not going to show them all those other laboratory reports for the same samples where those numbers were higher. So it's all a question of just bamboozling the client. It has nothing to do with sampling or the validity of sampling or what's even really there. So indoor versus outdoor. This is the big myth. Indoor versus outdoor. Virtually every certified mold guy out there, that's what they're doing. They're claiming that they are collecting samples and comparing indoor samples to outdoor samples. They aren't doing any such thing, number one. And number two is, even if they could compare those data, there is no science to back up the comparison. So, for example, in this particular case, we have properties with no mold problems. And what I've done is I've collected simultaneous collections. That is, I'm on a walkie-talkie inside. I've got a technician walkie-talkie outside. And I say, okay, go ahead and begin your sample. We're using the exact same sampling devices. We're using the same sampling times. We're using the same laboratories. But we're collecting samples simultaneously indoors and outdoors to see what it looks like. So in this particular case, where we have properties that don't have mold problems, according to the certified mold guys that are out there, the spore concentrations inside should be lower than outside. But what we really find is that about half the time, the spore concentrations inside are going to be higher than outside. In fact, sometimes they're going to be significantly higher. In this particular case, we've got it truncated. If we were to take this data point and really put it where it needs to be, it'd be off the chart. So I've had to truncate it and bring it down to here. But these are all samples where the indoor is higher than the outdoor. and the outdoor is represented by my blue line here. And then we've got 50% of the time the spore concentrations inside are lower than the outdoor concentrations. There is no way that you can look at two data points and say one's inside, one's outside, is higher, is lower. You have no idea what the data is. But even if you really did know what it was, there is nothing to support the argument that concentrations inside higher than those concentrations outside indicate a mold problem. It's just not science. It's snake oil. Similarly, for properties, here we've got confirmed mold problems. We've got 56 simultaneous collections, indoor and outdoor. So what we would expect, according to the certified mold guys that are out there, we would expect that the indoor concentrations always have to be higher than the outdoor concentrations. And yet again, we see that 50% of the time they are, 50% of the time they're not. And this idea that somebody is just making a decision based on a so-called indoor-outdoor comparison, it's all myth. It is just all a question of fooling the victim. When we look at our park parameters, precision, accuracy, representativeness, comparability, and completeness, those are known as the park parameters, we get into comparability. So when we're comparing two data, it would be like as if you contacted your friend who's playing, and you know that the Broncos are playing the Raiders, and you said to your friend, well, what is the score? And your friend says, it's 21. Okay, well, it's 21, but you don't know who's winning the football game. Well, actually, you do. The Broncos are winning. You don't know by how much the Broncos are beating the Raiders. But you know somebody scored 21 points. So you've only got half the information. So you have to ask the person, okay, well, what is the full score? It's 21-3. Okay, now you can compare the two data. Now you know the Broncos are winning because they have 21 points and the Raiders have 3 points. That's the comparison. In the case of the mold industry, there are no standards. Typically, they're going to be using bogus arbitrary values that they've pulled out of thin air. They'll be using their bogus indoor-outdoor comparisons. They virtually never have any a priori DQOs established. The U.S. CDC makes it very, very clear that if you're going to waste your money on this, at least make sure that the consultant that you've hired is going to have a priori data quality objectives, and they can tell you up front what are the decision criteria that they're going to be using. There is virtually no organization out there that says collect sampling. In my particular state, Colorado, CDPHE says the Colorado Department of Public Health and the Environment does not recommend testing as a first step to determine if you have a mold problem. This is kind of ironic because there's, I think they're defunct now, a group of pseudoscientists, junk scientists called the Colorado Association of Meth and Mold Professionals, a group who knows nothing about meth, they know nothing about mold, and they try to make themselves seem professional, and even though it's a criminal activity, a state regulator actually also served on the board of directors on this group, and they were running around collecting samples, and yet within their own organization, CDPHE says don't do this. The state of New Jersey, the state of New York, the state of Pennsylvania, Nevada, all of these states all say do not collect samples. The samples are meaningless. Do not waste your time. Connecticut, California, Nevada, all these states say don't be collecting samples. University of Connecticut Health Sciences Center Division of Occupational Environmental Medicine says do not collect air samples. They're meaningless. New York City Department of Health and Mental Hygiene states air sampling for fungi should not be a part of routine assessment. This is because decisions about appropriate remediation strategies can usually be made on the basis of a visual inspection. U.S. Centers for Disease Control says, other than in a controlled, limited research setting, the sampling for biological agents in the environment cannot be meaningfully interpreted and would not significantly affect relevant decisions regarding remediation, reoccupancy, handling or disposal of waste and debris, work protection, or public safety. In other words, even if you have these numbers, they're meaningless. Also, NIOSH says building consultants all often recommend and perform clearance sampling for air sampling after remediation work, but it's not recommended because there is no scientific basis for the use of air sampling for this purpose. It is junk science. It is complete junk science. So how do we do it? We look. That's it. We look. according to the U.S. Institutes of Medicine National Academy of Sciences.